and they are joined with these people, and one paper is still in progress, but I will not refer very explicitly. It will be all over the place. So the topic is then in general economic ambiguity theories. I will explain them, and in particular how they can interact with the psychological decision from experience literature. And then there are useful connections. Economics, it's mostly theoretical. Psychology is usually experimental, and more connection between those can benefit, everybody can benefit from it. That I want to explain today. And the outline of my talk is, first, I'm going to talk about the history of ambiguity in economics, tell a bit about that. Then about the famous Ellsberg paradox. It will be useful for us today. Then some popular ambiguity theories, first a category that have some drawbacks, then some further ones that have fewer drawbacks that I like more. Then will be implications of these theories for decision from experience, these ambiguity, also the other way around, how decision from experience findings have implications for ambiguity theories for the economists, and then there will be a happy conclusion. That's the plan of today, but I'm going to start with history of ambiguity in the economic literature. Well, first what it is, then why is it important, and why did it more or less suddenly become popular in the end of the 1990s and not before? I'll tell a bit about that. And I assume that people here, and then the many non-economists, so I'll tell a bit about that. Usually we start ambiguity literature with Keynes and Knight, 1921. They independently wrote books in which they emphasized that we should think more about situations of risk uncertainty where we don't know probabilities. People work with probabilities, expectation, all these things already. But in many situations, we don't know them, and we have to think about what to do then. They emphasize that both of them independently, because real uncertainty, real difficult ways to handle is when there are new risks that you did not see before. When you have no statistics, you have no probabilities, then it's much harder to see what to do with those uncertainties. When unique events happen, one time maybe inflation going up next year, the economy is in a different state than it ever was before, a unique event. How can you handle those uncertainties? In many situations, if you have repeated uncertainties, if you have statistics, probabilities, you can do sort of calculated risks. You can insure, you can hedge, you can handle and avoid those risks. But those new unique events, they are the real test for if a businessman can handle uncertainty very well. So that's what these authors argued. And for instance, financial crises happen every now and then, and they are always by unforeseen events that we didn't see before, that were not in our models, that are new events, and we cannot hedge against them. So those are the real difficult cases of uncertainty. We should think about it. Well, and ambiguity, unknown probabilities, especially prevailing in economics, more than maybe in other fields. Like in health, often we already treated thousands of patients. We know the probabilities, we know the risk of the side effects. So that, but in economics, with macroeconomics, for instance, you cannot do an experiment with the economic state of your country. This has often been written, for instance, Samuelson and his co-author, they wrote about it, and they said economists cannot perform the controlled experiments of chemists or biologists because they cannot easily control other important factors. So in economics, it's more than in other fields, although in many fields, unknown probabilities are important, but to the economics. The first answer came under this Keynes-Knight question: what should we do with it when we have no probabilities? How handle that ambiguity? That was by Ramsey, De Finetti, Savage, with some people. And they say, it sounds silly what I say, but it was in fact deep thinking. There are the photos. They said, well, if we have no probabilities, if we don't know probabilities, then still use probabilities. And if you don't know what they are, give your best guess. And then after that, it's business as usual. And because these probabilities are not objective, let's just call them subjective. Well, if I describe their contribution in this manner, it sounds like very silly, just put in whatever you like. But in fact, this was I think Savage 54 was the best, the greatest contribution to all of our field. He gave action absolutely brilliant. So very deep thinking was behind it, making this normatively convincing, all these things. But surely empirically, things are not as easy. There were already Keynes 1921. Now there was Ellsberg 1961. He put up a paradox showing that things may not be as easy as those authors before said, surely empirically. And his paradox showed that often we just can't use probabilities in any sense. We have unknown probabilities. There's no regular manner to use probabilities. We need fundamentally new tools and models. Well, Ellsberg, he did other things in his life, and maybe my generation know, maybe the newer generation don't know so much, but he's very famous for other things. He released Pentagon papers showing bad things in Vietnam War going on. Then he was the most searched criminal in the United States for having published these confidential things. In the end, the judge spoke free, he could go. But he's much more well-known for those things. And recently, when Trump became president, he wrote a book showing how Trump is doing many things very similar to Nixon, that many things are repeating. So that was also, there's influential there. I like this book. But anyway, today I will talk about what he did in our field in decision theory, which in a way he found it with his paradox. So I'll describe Ellsberg paradox because it's useful for our purposes today. So the paradox says, imagine there's a known urn K. It contains 100 balls. Every ball is red or black in color. And we know the composition. We know 50 are red, 50 are black. That is a known urn. There's also an unknown ambiguous urn. It also contains 100 balls. Also, every ball has color red or black, but here we don't know the composition. Maybe 85 balls are red, or maybe 27 balls are red. We just don't know. The composition is unknown in that urn. Now we're going to draw a ball at random blindly from both urns. We're going to inspect their color, and then you receive a money amount depending on the color of the ball drawn and your preference over that. We're going to talk about it. Here's some notation. This is a notation where if the ball drawn from the known urn K is red, you get 20 euro. And otherwise, so if that ball is black, you get nothing. And nothing, zero, I don't write it. So that's how I denote gambles on color. With that notation, people are asked, for instance, imagine you can gamble on the color red, but you can choose whether you gamble on the known urn or on the unknown ambiguous urn. Would you rather get 20 euro if the known urn ball has the color red, or if this ambiguous urn ball has the color red? And people are asked about their preferences, and I don't know how people in the audience feel about it, but usually we find strict preference that manner. People usually rather have the known probability than the ambiguous, the unknown probability. That holds for the color red, of course, the same story, black or red color doesn't matter. Also for black, you rather gamble on black from known than on black from ambiguous unknown. We have these two very obvious preferences, and Ellsberg didn't really do the experiment. It was only thought experiment. Many experiments, very well done, real incentives and so on, have shown this is the common preference pattern that we found. Now, these two very simple preferences are already enough to refute any concept of probability, at least in any common way. And I'll explain. Imagine you do maybe this subjective expected utility model of Savage. You assign subjective probabilities, and then you do expected utility. Or even if you do any other model based on probabilities, the moment you have that first preference in terms of probability, it implies that if you work with probabilities here, it's the same outcome. Of course, you choose the gamble that has the biggest probability of giving the gain. It's a stochastic dominance. So the first preference implies that your subjective probability of red from the known urn must then be bigger than the subjective probability of red from the ambiguous urn. For black, same story. We also get that inequality. But now these two inequalities give us a contradiction because we have here complementary probabilities. Their sum is 1. Here we also have complementary probabilities. Sum must also be 1. But but two big numbers cannot give the same sum as two small numbers. We have a contradiction. So this cannot be. So this very simple experiment shows that any model based on probability, at least in any common sense, cannot accommodate these data. So that's already anything of subjective probability is violated. So that's a very fundamental problem. That means if we want to handle ambiguity and to capture those phenomena, they are empirically prevailing, and also the home bias in finance is like that. So it's not just important phenomena have that. We need something fundamentally new, something going beyond probability. And that's a bit of a difficult thing. That's hard to think about. Because maybe if you have probabilities and you want to calculate, evaluate, you can do integration, you can calculate expected value, expected utility, all these things. But if you have only events, if you say, if rain tomorrow, you get 20 euro. If no rain tomorrow, you get 35 euro. You don't even know what calculation can you do with events. It's really hard. It's a concept, it takes much creativity to invent a model that can do that. A long time, people just didn't know what to do about it. So only in the late 1980s, and it was exceptional creativity, came Gilboa Schmeidler. They were able to formulate decision models that could handle ambiguity. Actually, the models had been formulated before, but not as decision context. They could show how it is decision relevant. And that was really a big intellectual step forward to exceptional creativity. So now this explains also a bit, surely in economics, it has been known since the 1920s and the 1960s that surely that we need ambiguity models. Economics needs them urgently. So why in all the 70s, 80s, we saw all kinds of models for risk, we saw nothing of ambiguity. How come? Not because that was not important, but because it was so difficult. That's why it took so long. And only the end of the 1980s, when people introduced ambiguity, when they introduced ambiguity models, showed the field how to do it. Many other people could follow, make variations, and the field took off. But then there was much to catch up with. So therefore, it was only in the late 1980s did models started, and it takes a few decades before many people know it. And only now it's spreading in all kinds of fields, especially in economics. Economics is much, because in almost every field of economics, if you work in labor economics, in organization, whatever, ambiguity is central there. Maybe people are unemployed because their ambiguity attitude is doing it. All these things should be investigated, and economics is much catching up. That explains why nowadays so many people are working on ambiguity, why it's popular, it's spreading in all fields, and right so. So that's a bit about the history of ambiguity, how it started and why it started. I should say that Gilboa Schmeidler, they introduced models, but they were normatively motivated. They wanted to capture rational behavior. They thought that rational people may and should behave like in the Algebraic paradox is displayed. Many people see it differently. I also see it differently. Many people think that this ambiguity attitude is irrational, and they only mostly study it for empirical purposes, that in my case. And surely empirically it's happening. So empirically we surely need ambiguity models. But some people also think normative. And Gilboa Schmeidler, they did not look much at empirical data or findings. They were talking about rational. But okay, we can use the models still, they are nice. Then since that time, many models have been introduced in the theory of economics. And I mentioned we will not discuss them all, there are many. And we will not even read them all. I just listed, I kept on listing. Then around 2015, I stopped adding things to this slide, and several more have come. Anyway, there's a bit of a problem. There are many models, and if you want to use ambiguity, and all models give different results, which should you use? At the moment, we are in a stage of many models. We should select and have competition between the models, find out the few that are really good and the rest are not so interesting. That's a stage, and decision from experience can help a lot in there. That's a stage where we are now. But all those models that I mentioned here, they all are like Gilboa Schmeidler, they are normatively motivated. That's what the authors say. They don't link much at what the empirical findings are. Not enough to my taste. That's a bit missing. And that's why decision from experience can be useful here. And they all assume expected utility for risk. I mean, no, empirically that doesn't hold. For empirical purposes, not so good. They also have a particular multi-stage principles that they assume in the Anscombe-Aumann framework that I will not say much about, but that are also problematic. So all this theoretical work is going on, but empirically it's a bit problematic, the models that are right here. And also many of these models are very general. They use maybe sets of priors. These things have such high cardinality. They are too general. You need more specific assumption before you can do data fitting. So it's theoretical work, but maybe a bit somewhat ivory tower. Needs more before one can connect with empirical reality. Let me describe in a bit more detail a few popular ambiguity models. And first, I'm going to assume models that I described now, they are the most popular ones. They all use the Anscombe-Aumann framework, as it's called. I will not say much about it, although I think it's not a very good framework. At least it was good to start to simplify mathematics. But for empirical purpose, there are too many drawbacks to the model to work well. Anyway, that Anscombe-Aumann model, it assumes that, well, usually at the end of the decision process, people get a money amount. Anscombe-Aumann framework says, no, in the end, you don't get the money amount, but you get a probability distribution over money. So they add an extra stage to existing models where probability risks come in. Then they assume that those probability distributions over money, those lotteries that you get at the end as a prize, that they are evaluated by the expected utility model. And we all know that's empirically problematic, but they still assume it. So that's already one problem, that you need expected utility for risk. Another problem is that these models, you have multi-stage. You have to do, they are in fact assuming dynamic optimization that people sometimes call backward induction. Now, backward induction may be natural and okay for classical expected utility, but they are highly problematic when the moment you leave expected utility. The moment you do anything with ambiguity, those dynamic principles are very problematic, much violated empirically and very complex. So those are quite drawbacks. So anyway, this Anscombe-Aumann framework is, so why do people use it if I mention all these drawbacks? It is because it gives mathematically, it's very convenient. You have expected utility, you get linearity and probability mixing. I'm not going to explain all of this, but then you can use all the mathematical libraries filled with linear analysis, and you can prove theorems. That's why it's very popular. It's sort of pragmatic way to work. Now, I'm going to describe a few models that all use this Anscombe-Aumann framework, but I will not explain, I will leave out, I will assume that this Anscombe-Aumann stage has already been handled, that we have outcomes, so I can present a bit simple ways how the models are, but then we have in the back of our mind that there's always this Anscombe-Aumann complication at the back of them. I just will not write it for simplicity, but it is a bit of a problematic. So now I mention a few theories based on that. One theory is multiple prior max-min expected utility that Gilboa Schmeider 89 introduced. This is before, but they made it a decision model. This model says, let us look at the ambiguous, the unknown earn with unknown composition. And we look at the gamble on the collar. Imagine you get some money amount, capital M dollar, if the ball drawn from that urn is red. So now it's ambiguous, I don't write because we know now it's ambiguous. And if black, you get a small m dollar. How would you evaluate such a gamble? And so I'm leaving out the Anscombe-Aumann, I said it already. Well, now the probability of red, the composition of the urn is unknown. So how can you handle it? So that's the ambiguity question. Well, what they say is you should specify an interval of possible values that it can have, a set of the value that you think, maybe you think, I think the composition is between 0.2 and 0.85. Then you specify that interval. Those are all the probabilities that you consider to be possible, and the ones outside you think they are not possible to happen. So the true composition PR is between the minimum and the maximum possibility. You specify such a set of possible probabilities. Then what you do in your evaluation of that gamble that I wrote here, for every possible probability, you can calculate the expected utility. If that were the true probability, and you could hear the rooster of my neighbors anyway, and then you take the minimum of all those expected utilities. So the infimum, the most pessimistic thing that you can think of, that's how you handle. So you handle this ambiguity in a very pessimistic manner. That is the max-min expected utility model. And for instance, if capital M is bigger than small m, so that this R event is the most favorable event, then the evaluation, you take the most pessimistic evaluation. That's where the good event has the minimal probability possible. That's that minimal probability. Then this expected utility is the minimal expected utility that you can get. That's how you evaluate that gamble. That's how the model works. Now, I'm going to go on. Anyway, this model is a bit pessimistic. People think too pessimistic. Let me go on to the next model. First, I present a few more models, then I discuss a little bit more these models. There are some more things to be said. But first, let me mention the popular variation of this. This is the alpha max min model. And I'm going to be a bit fast. I think I should reckon with time. Anyway, they do much the same thing as this max min. Only, and we will not read the formula, but I just say in words. What they do is they don't only look at the minimal expected utility, but they also look at the maximal expected utility over the set of priors, and they take a mix of those two. And the weight you give, the weight alpha that you give to the minimum or to the infimum, that is, if that weight is very big, you're very pessimistic. If the weight is 1, you're doing this max-min that we saw before. So the bigger the weight you give to the minimal, the more pessimistic, the more ambiguity averse you are. So that's how this model works. So this number alpha is then an index of your ambiguity aversion. And this model is quite popular, quite good, has many positive features. But another model is very popular. It's a smooth model. And this may be the most popular model that exists. This model says what we're going to do. We're going to assume that you don't know the composition of the urn, the true probability of red. We're going to impose a second order subjective probability distribution, your subjective probability that the urn has a particular composition. We specify that. And then when we evaluate the act, I'll build it up slowly. If you know that the true probability, the composition of the urn is that PR, then if you know that for sure, then you just calculate expected utility. But in reality, you don't know, you bring in the second order distribution. If the second order probability of PR being that value has some value d mu, then you multiply this expected utility by the second order probability of that being the right one. And then you take the weighted average with all those. So you take a look at all the possible compositions. For each, you take the second order distribution, you take the average expected utility. Now, maybe I don't have some specialists who can follow, can see that in this formula, not much spectacular is happening. This is just regular expected utility, nothing ambiguous going on. This is just a regular double integral. But they bring in novelty, they bring in the brown thing that they add now, a nonlinear transformation. The second order, they non-linearly transform these values. That's how they deviate from Bayesianism, how they get ambiguity attitude in. And they can let that be very concave. They bring in sort of extra risk aversion on top of risk aversion, extra risk aversion because of ambiguity, and that's ambiguity aversion. So that's how this model works. It's very popular because you don't need any new way of calculating. You can just do traditional expected utility integration. So numerically it's very easy. So that makes it very popular. But there are all kinds of drawbacks to the model. Anyway, the third model is Schokke expected utility that Schmeidler introduced in 1989. Schmeidler said, also called rank-dependent utility, he said, if here we have the ambiguous urn, how do we evaluate? Well, let me tell it only, you take a in expected utility service, you take an additive probability measure. Now you take a non-additive measure. You relax the law of additivity. And then if capital M is the best outcome, you evaluate the gamble in this manner. You take this W value like probability, but non-additive, and then it looks a bit like expected utility. But here you treat the best outcome differently than the worst outcome. That's why it's ring dependent. And so this is a generalization of expected utility that Schmeidler proposed in the Anscombe-Aumann framework. Well, these models, all kind of things, more things can be discussed about them. For instance, the multiple prior model, the max-min and the alpha max-min, they require you to specify a set of priors. And that, if there's only one event like here is doable, it's interval. But if there are many events, there are so many sets of many priors and even more sets of prior. This is a parameter of too high cardinality to be tractable. Too many models are incorporated here. And people don't know, there are all kind of fishy things people do to work with it. But that's a big problem. It's a bit similar here, the smooth model. There are many, if for one event it's doable, but if there are already many basic events, many states of nature, 5 or so, then there are many probability measures over them and even many more second order probabilities. So this second order probability measure is, again, such high cardinality, such generality, you cannot really handle it empirically. So when people use it, they also use fishy things that I will not discuss very much. Bit similar, the model I mentioned here. These non-additive measures, there are many people usually think allowing any non-additive measure is too general. It's not as bad as the others one, less general, but still too general. This is exponential in the number of states of nature, also too general to be really suited for predictions. So here also people are not so happy with the models. And that's why all these models are a bit, as I said it before, a bit general and not really very tractable. And people do fishy things to apply. By the way, any question or remark, please interrupt me. I like that. It's lively. Just feel free to do, of course. Now, I mentioned some further ambiguity theories, but they have...
I think it will be better if you enlarge the screen so we don't see the PowerPoint, just the slide.
Yeah, okay. Indeed, I go back to presentation mode now. I should.
Sorry.
Yeah, I had left it, but you're right. Good to remind me of it. So now I go back to the presentation mode. There we are. So now I present a few more ambiguity theories, but they do not assume that Anscombe-Aumann framework. And that's, I didn't say much about it, but I told you before that's a big limitation. These theories, I like them more, these ambiguity theories in economic literature, because they don't have that framework. So there should expect you that already Schmeitel had it, but Gilboa, his student 87, also had it. This Gilboa paper is not so very well known, but I think it's a magnificent paper. That's really a good model of ambiguity, much better than the other things I mentioned so far, I think. But when I write the formulas, it's just like what I wrote with Schmeitel, non-additive measure, and then the evaluation, the rank-dependent formula. And this is in fact Kahneman, Tversky, and prospect theory. When they, I think 92, everybody knows Kahneman, Tversky improved the probability weighting. But I think for me, a bigger move is that they also allowed for ambiguity, unknown probability. They could handle that also. They were in fact using a formula like the Gilboa. They brought in sign, reference dependent, all these things. These are empirically important. But today I only speak about gains, so I leave that out. So therefore, this is essentially prospect theory, and that is my favorite theory of ambiguity. And the big point here, I didn't express it, that there is no Anscombe-Aumann framework. They are not assuming expected free. They are not assuming two-stage dynamic optimization, just money amounts, simple outcomes, much better empirically. So that's already a big improvement. But the drawback that I mentioned for Schmeitel, that non-additive measure that is too general, that drawback still holds here. We need a specification. We need to be more specific if we want to have a theory that can give us predictions and descriptions. So that's now coming. That's then the theory I work on, of course. My favorite theory, it will not surprise you, but it's a special case of prospect theory, you could say, a special case of a Gilboa model. And I'm going to tell you how that works. But before, to prepare for that, I return to Ellsberg paradox. And you remember I told you, Ellsberg showed that we absolutely cannot use probability in any sense, at least in any common way. I added a few times, because we're going to use probabilities after all. And that's an insight that was first brought by Chu and Saji in a 2008 paper. They said, wait a moment, we see all this, but let's not jump to conclusions. Let's not be too fast. We think you can use probabilities still and model ambiguity while using probabilities. And we think that in this Ellsberg urn with two colors, we think both in a known urn, but also in the ambiguous urn, we think it's quite reasonable to say the probabilities are 0.5. So how can they escape from this paradox? They say, but our point is, these ambiguous probabilities are treated differently than the known probabilities. You should not say that there are no probabilities here, but you should say that there are probabilities, but you treat them differently. For instance, you can do probability weighting, formula, apply a probability weight, but then you have a more pessimistic one for ambiguous than for risk. For instance, here we take probability 0.5, but here the weight of 0.5 is smaller than here. And that's how we can accommodate the Ellsberg paradox. So that's what Chu and Saji said. And it makes sense. And it's a good approach. And it means a revival of the use of probabilities in ambiguity. Now, you cannot imagine when this 10 or 15 years this was introduced and people, myself, others started working, how much trouble with referees we had, because it was completely ingrained in the brains of every economist. Ellsberg, no probability. Ellsberg, no probability. So if you don't say Ellsberg probability, say this cannot be true, we don't believe it. It really needed to grow on people that they understand, yeah, you can do ambiguity, but you can use probabilities. So that was the insight of Chu and Saji. But one thing I said, you can, for instance, do probability weighting.
I think David has a question. Sorry.
Yes?
Hey, Peter. So this approach reminds me very much of this idea that there are probabilities, but in fact, people assign different utility functions to gaining, 20 euros from different sources. I think it's a Vernon-Smith paper, right? How is this different?
Very different. Vernon Smith is quite in the spirit of the smooth model, and I didn't have much time to speak about it, but I'm happy to. I think the smooth model, maybe you remember, you were applying functions to utility, to outcomes, to events. And then I think you're barking up the wrong tree. Ambiguity is about events you don't know about. It's not about outcomes. So I think models that use functions operating on events, like most of the ones I presented, they make sense. But models that work, so models that work, for instance, the prevailing empirical finding is what they call the fourfold pattern. Your ambiguity averse for unlikely events, your ambiguity seeking for unlikely events and gains, your ambiguity averse for likely events. Those utility models like smooth models cannot accommodate that because they only look at the outcomes. For them, the outcomes determine your ambiguity attitude, not the events. So I think this Vernon Smith idea and the smooth model, I don't like the smooth model. I think they're barking up the wrong tree.
Yeah, but what I really mean is that empirically, it's very hard to determine whether people have different weighting functions for the probabilities or they implicitly use different utilities from gains from various sources.
I think it's very easy to see empirically because of the fourfold pattern. The fourfold immediately classifies smooth. Yeah.
Okay, fine.
I always enjoy saying negative things about these models. So thanks, Dave.
Okay, right. All right, go.
Okay, so we go on. Now, Chu and Saad, you had that insight, but unfortunately, they did not use probability weighting like prospect theory does. They use other betweenness model that don't work well. So in that sense, that approach was not so very good, I think. But that basic insight was really, it's almost trivial, but still it was a sort of a breakthrough. So now I come with what I call the sort method, which is a special case of the Geboa and the Kahneman-Tversky model. The source method says, now how do you evaluate this gamble? First, you take a sort of best guess probability. You do assign a probability, and it's a bit, how do you do it? That's a non-trivial question, much to say about. But for now, let's assume you find a sensible way. For instance, Albert easy because of symmetry must be 0.5. And then you do apply a probability weighting function to it. And then things work quite nicely. So then in this situation, where we have this urn, you say, I take my best guess probability of red. I apply the transformation function to it, and then I do this rank-dependent prospect theory type evaluation. So this model is a special case of what I showed before. Before, these people said you put here any non-additive function you like. I already said that's too general. This is a special case, a special way where that non-additive function is a transform of probability. And that's a special case. And that turns out to be more specific. And that's, as I will show in a moment, is good enough to do prediction and all these things. And the big point here, how can you handle it? I mean, you let the weighting function depend on the source of uncertainty. That's where you deviate from other models. Different ambiguous probabilities are treated differently than known probabilities. That's what brings the novelty here, what makes everything going. So for instance, I already explained a bit, but let me do again. Here in the Ellsberg paradox, we assign probability 0.5 to all of them. So here we don't say there's no inequality here. They are all 0.5, but only these we weight more pessimistically than these. And then we can accommodate, that's easy. So that's how it works. And our big question is, how can you get those probabilities? You must find best guess probabilities. How can you do it? And there's quite some work on that. It often can be done, but not always, and I'll discuss more. And also, is the theory now still too general, or can you do data fitting and prediction with it? But it turns out that you can do it. There was already, this is already quite a while back, 2011, we had a paper where with co-authors, we did such things. And for instance, we did experiment with Ellsberg on only 20 colors, and then we could measure the whole thing, the utility function. We could measure the probability weighting and we did it. For instance, we did it for Ellsberg urns. More interesting is to do it for natural events that happen. We also did that. So here, for instance, we did for one subject here at the data, we did the CAC 40. That's this experiment was done in Paris. This is a Paris stock index. We did Paris temperature. For all these things were equal likely, we could find the probabilities and we could do all these things. And for per subject, we needed half an hour. Then we could measure the whole decision model, including all these curves. We could infer many things from it. Are people ambiguity averse? Do they have more extremity orientedness? All these things. But I have no time to discuss it much. And we could do it, the curves here are for parametric. We also could do it non-parametrically without making any parametric assumption, showing that these models can fit data well. Then there was a follow-up paper where we showed that we could do it much more easily than in that here in 5 minutes for every subject, we could measure the ambiguity attitude using matching probabilities, then utilities and risk cancels. But let me not get into that. So in one sentence, this source theory, the source method, what it says, it shows how you can use probability weighting function to capture uncertainty and ambiguity attitudes. That's what this theory does. And, well, and now novelty, how new is this? If this were an economic audience, I could probably say, well, this is a new theory. We introduced it with the first array. But for this audience, it's more difficult because in decision from experience, everybody has been doing this already for at least a decade. You know, people have been measuring the probability weighting function for decision from description, also from decision from experience, seeing what the difference is. So this is already common practice. So how can I say that we do something new? But now I have to say, indeed, this idea of using probability weighting functions to capture has been already found in 1961, recommended. Kahneman-Tversky already 79 mentioned it, that this is a good way to model. So that idea in itself is not new. The novelty that we did is that we played the economic games with it. And as we made it mathematical, we formalized it completely. And also we gave preference axioms that capture it, simple preference conditions that capture it. And surely economists want to have that, otherwise they don't take a model very seriously. Those things, and maybe in psychology, there has been a generation, concept of first measurement in psychology was done, and nowadays has almost disappeared in psychology. But it's really, you need those things. And for instance, if I made, I think the most famous preference explanation that exists in it is Savage 1954. And he was about the expected utility. Well, that existed long before. But the thing he added was preference axioms. Simple conditions that, for instance, he showed mostly the sure thing principle is what captures expected utility. And that really brought much new, and then people understood the sure thing principle. That's what we have to think about. And if we want to generalize, that's what we have to generalize. If we want to falsify, that's what we have to falsify. Then we know what it means. So in those things, so many people, this approach has been used in decision from experience for a decade in many fields, but we are now the first who add these actions and all these things. And that's in the sense, in a theoretical sense, we bring novelty here, also some empirical things. But anyway, so now what are implications that the decision from experience field, what can people learn from these things? I'll say a few things about that. So using the insight from ambiguity theory. And first, I want to say a few things about the gap, decision from experience, decision from description. People may not be very happy, but I'm a bit critical about the writing on that gap. The first people who wrote about it were writing that the gap was a reversal. They said decision from description, then rare events are overweighted. However, decision from experience the other way around. Rare events are underweighted. Now, that would be shocking, such a reversal, completely the opposite. But I think there were a big question always when you do this source method, which they were in a way doing, which probabilities, what are those PR probabilities? How do you get them? They were using the objective probabilities that the subject don't know, for instance. There have been many more studies, at least my reading from the literature, there's this Wolf et al. Survey paper, is there is a gap, but it's not really a reversal. We don't get reversal. And also there's a recent paper, Ido, he was among the early people. Maybe we don't read this text entirely, but he also described it where there is a gap, but there's not really a reversal. That's my understanding of the literature nowadays. And then things become a bit different. Then
can I have a comment? Or
yes.
So, the Wolf et al. Focus on what's known as the sampling paradigm, which is in a sense when you get weighting that are, let's say, more similar to description compared to what's known as the I don't know, decision from feedback. In the decision from feedback, there is an extreme difference compared to description. So there are, within the name experience, there are two subdomains: decision from sampling and decision from feedback. In the decision from feedback, you get large gap.
It's indeed allowed. The gap can sometimes be large, and I think, but anyway, I think in itself the gap means that there's a difference. It can be big or small. That doesn't mean reversal. And if you think about that as a difference, I can't think of any hypothesis that is less surprising than that. I think nobody in the world will ever think that decision from experience and decision from description give the same thing. Of course, there will be differences, and every person working ambiguity, different sources of ambiguity, of course, there will be differences. There's nothing surprising about that. So they say, hey, we have a gap. Yeah, come on. And nobody in the world would expect to be no gap. So I find a bit this writing about the gap as a central remarkable finding. I'm not so happy with that way of writing about things. Of course, there are different. We should study them. That's interesting. There is something that is interesting, and that could be a paradox, but I haven't seen it mentioned or discussed much in decision from experience literature. But that is the common finding in the ambiguity literature is that phenomena for risk, they happen also for uncertainty ambiguity, but in a more pronounced manner. That's the common finding. Therefore, usually with ambiguity, you expect if rare events are overweighted for risk, they will be more overweighted for ambiguity. But that's not, in decision from experience, it's a bit different. The decision from experience is ambiguity, and decision from well, not but usually decision from description is risk. I think a common finding is still that the overweighting of the rare events is less in decision from experience than in decision from description.
Sorry to budge, but again, in decision from feedback, you do find underweighting and you do find a complete reversal. The two papers that you cite are both on decision from sampling, but not on decision from feedback. And in decision from feedback, you get very drastic underweighting of small probabilities.
Okay, I'm not sure about that. I should study it more then, but maybe. Anyway, well, one big difficulty in many studies is which probability do you use as the input of the weighting function? I think there's a lot going on there that's not at all clear. And also in these studies, I saw many things that I disagreed a bit with. So the debate, it's not that close. Anyway, let me, so this, you could say this is a sort of ambiguity paradox. In decisions from experience, people are finding something that you usually don't find in ambiguity. That's a bit surprising, maybe. It's not very surprising because it has been known if there are ambiguous sources that people are more familiar with, it may be that this is less. This has been seen more often, but it is an exceptional finding. And that's one of the interesting things. I think decision from experience doesn't give a risk paradox, but it gives an ambiguity paradox a little bit. But that's one of the interesting things. And the ambiguity literature can bring that in. Another thing is, I already told you a bit that source theory gives axioms. It formulates properties. When can you use probability weighting to capture ambiguity, uncertainty attitudes, and when not? And I cannot say much about the axiom, don't have time, but vaguely speaking, your uncertainty source must be uniform. All the events must have a sort of same degree of ambiguity aversion and ambiguity sensitivity perception in its source, then it works. And that's not always. For instance, there's the famous three-color Ellsberg paradox that is not uniform. It doesn't satisfy the axioms. There you cannot use probability weighting in any sense to capture what is going on. So that's one of the things to be aware of. And if you see the conditions, then you can relate to it. Then you can, if you see some source already before you look at data, you can ask yourself, would this be a uniform source or not? And you know that you should test for that. The events in different situations have a similar degree of ambiguity. So in that sense, the ambiguity papers can give new insights into decision from experience. In decision from people usually just assume and do data fitting and data prediction, but with the action you can better target the critical conditions to test. So that's one thing where it would be of interest for the decision from experience field to learn from the ambiguity theories. And also, which probabilities can you use as inputs? And then that's there are particular conditions that probability events must satisfy for these probabilities to be used as inputs. In decision from experience, people looked at all kinds of the true objective probabilities or the relative frequency that were actually sampled by the subject, or maybe people use introspective expressions of belief as inputs. But these probabilities, to what extent can they be used to be the input of probability weighting? There are conditions there, and it's nice to learn about these conditions, to understand better which of these could be better suited for that purpose. That's another point of debate where decision from experience could learn from the ambiguity literature. So about this, I haven't seen these things discussed in that literature. So that's another example. There's this paper, I like it much. It's Spiliopoulos and Hertwig. It's forthcoming in Journal of Experimental Psychology Journal. And I like that paper much because that is really already using ambiguity theories and insights from ambiguity theories to do decision from experience. I think that's really a promising way to go. So I enjoyed it much. And for instance, they look at the ambiguity theory like economists in the ivory tower are doing. Is that, but when the rubber hits the road, when you really try to fit data, and you see better what's going on. These authors do it. They wrote opinions about the current ambiguity literature that agree completely with my opinion, what I said before. And they write about models of decision-making under ambiguity are typically extremely complex. I told you this sets of priors, for instance, requiring multiple priors over first-order beliefs or second-order beliefs over priors. They are computationally expensive, and we are not optimistic that they can be estimated as latent variables. So and that's quite my opinion also about the literature. And they continue to say, for this reason, we use a two-stage model of decision-making under ambiguity. Now, what do they mean with two-stage model? I think no economist will ever have heard of it, but in this audience, there may be some people who know that Tversky and some co-authors, they proposed a model that they call two-stage. They said, we assume in ambiguity, first people determine their subjective beliefs in the events, and then they apply a probability weighting function to those subjective beliefs. That was the two-stage model of ambiguity. And maybe if you hear it like that, you think, isn't that exactly the same as a source method that Peter just put up? Doesn't this take away more novelty, or maybe take away all the novelty of everything that Peter has been proposing? My answer is no, it does not. My answer is the two-stage model is about as different from the source method as can be. And before I can explain that to you, I must express some criticism of the psychological literature. That is, in economics, if people write subjective probability, they assume it satisfies the additivity law. That's crucial. Do you satisfy additivity or not? That's the difference between day and night. Economics, if they write subjective probability, it satisfies additivity. In the psychological literature, if people use the term subjective probability, it need not be. It may very well be non-additive. It can be an introspective direct judgment of probability that's violating additivity. Now, but unfortunately, like this paper, Spilios and Hertwig, they use introspective measurements of belief as one. And you have to read almost nowhere they write whether it is supposed to satisfy additivity or not. But that's the difference between day and night. Anyway, the two-stage model is assuming that the expressions of subjective belief violate additivity. They can violate additivity. That means they are capturing a lot of ambiguity already. The source method that I mentioned, those probabilities, they must satisfy additivity. So nothing of ambiguity can be going on in that belief part. Only in my model, the probability weighting functions, they are non-additive. They depend on the source. They capture ambiguity. In a two-stage model, surely the way Tversky wanted it, the probability weighting function is just the probability weighting function on risk. It is the same for all sources. So in the two-stage model, ambiguity is captured through the beliefs. In the source method, it's captured through the probability weighting function. So they are very different. Now, coming back to Spilios and Hertwig, they say they do the two-stage model, but they are not doing that. They are doing the source method. They are assuming additive probabilities. So they are my closest friends that could be. But of course, well, we haven't published much on the source method yet. We're doing it. So, but I think they are not doing so. And also they are using a few ambiguity models that they don't use really in a good manner. So still, I think they and us can mutually benefit from our communication. This is another, but I like this paper much because this is already doing what I think both ambiguity and decision from experience need. They come together and they are doing that. So I like it much. More question like, can you, in about the weighting function that you're mentioning about, which of these parameters would be person dependent and stimuli independent or the other way around? In the ambiguity literature, all kind of speculations on that. I didn't see so much in decision from experience, but time is running out, so I will not. And there's one thing, I would really like if that came what I would call an outcome switch version of decision from experience. In economics, events can always be combined with different outcomes. In decision from experience, events are almost defined by the outcome they give. So if an event has best outcome, it always has best outcome. I would really like a treatment where you do decision from experience and where you tell your subject, if this lottery has 100 outcome, you don't get 100, but you get 0. If this lottery gives 30 outcome, you don't get 30, but you get, so that you change the outcomes so that the same events can be combined with different outcomes so that you can, anyway, maybe time is running out, but that's one of the things that really from the ambiguity literature suggests in decision, please do this. Take lotteries, but then modify the outcome, see how that modifies behavior of subjects. I would really hope that such studies will take place. Now, also the implication for ambiguity theory, I will not say much about it, but what we can learn, you should use more tractable model, as Spiliopoulos and Hedwig emphasize it very clearly. There's more the ambiguity aversion. You have non-EU for risk, person stimuli driven, that also the empirical findings of decision from experience can give lights on that, which model work best. Anyway, much to be learned also in that direction. Now, time for the conclusion. And the conclusion, my conclusion is people working in decision from experience and people working in ambiguity should have dinners together. So that's the conclusion of what I presented today. And that's then the end of my presentation.
Thank you. I think the conclusion was absolutely great. Okay. Not only dinner, lunch as well.
Yeah.
Anyways, now it's the time for questions. So you can raise your hand or write in the chat.
I think writing in chat is not so efficient. Maybe just speak, immediately speak will be easiest.
Yeah, you can speak it. If you are shy, you can write in the chat and then I will try to speak instead of.
Yeah, in chat, then somebody has to first read it and read it to the audience. And
Agree.
Great talk. I now understand all of these models better than I understood them before.
Yeah, that's one thing. Unfortunately, there are many models. We need selection there. As Spiliopoulos and Hedwig already helped quite a bit to bring some selection.
So Peter, I have a comment, not so much as a question. I think one of the things I dislike about the way many economists talk about ambiguity aversion is that they kind of assume that it is universal. In many experiments, some of them I've ran and some of them I've read, in fact, if you look at individuals, you find that the Ellsberg paradox is observed in a majority, but not in a very large majority, in some cases in less than 50%. And so I know you can, of course, if you have individual parameters, you can account for that. But somehow in the economic literature, people talk about, ambiguity aversion, and they assume that is universal, and everyone, almost every decision maker, basically succumbs to it. So I wonder what you think about that.
I think it may be more extremely than you are. I wrote it, the ambiguity literature can learn from decision that they should not focus on ambiguity aversion. I also think the literature is too much. Also, they only look at the Ellsberg paradox, which is not very relevant for practical decisions. It's indeed, I think this insensitive, this overweighting or underweighting of rare events is more than the aversion attraction component. And in almost every paper, I emphasize that people should not just look at the aversion dimension. So I completely agree with you.
Yeah, maybe I will. Thanks. So I also enjoyed the talk. It was very elegant. and clear. And it's helped me understand the literature better. But I think that one of the issues that in the decision from experience we worry, and this is related maybe to what David said, that small changes, for example, in part of the experiments that we ran, we give people full description, so there's no ambiguity. And now we let them have experience. They play the gamble several times, and we only pay for one randomly selected trial. And in that case, so in this experiment, we still have the effect of experience. So initially, they tend to overweight a rare event. For example, in one experiment, they have to select between 2 for sure, or a gamble that will pay them 101 with probability 1 in 100, 1 otherwise. So initially, people tend to go to the 101 with probability 1 in 100, but then and then they play it three times, and then they move to prefer the 2 for sure. And we tell them ahead of time that they're going to be paid for only one randomly selected trial. So my point is that maybe experience has effect in addition to ambiguity aversion. So in this case, there is no ambiguity, but experience has an effect.
Yes.
So the effect of experience might be more general than the effect of ambiguity.
I wouldn't call it more general, but there are different. Indeed, if subjects are forced to do all the sampling, then there is no ambiguity, but still experience can do things. So surely experience has more things than just ambiguity. I just agree with that.
Okay. So, and a related thing is that, so basically what we are thinking that happening in this experiment, and I know that economists have a hard time accepting that this is a useful way to approach, but what we think happening, and this is one of the early explanations for the Ellsberg paradox, that maybe the subject don't believe the experimenter. So basically, one explanation, old explanation for the Ellsberg paradox, is not elegant mathematically, but it's my intuition when I first heard it, that the subject, when you tell them, you say, well, maybe they're going to trick me.
Yeah.
So I prefer to have the risk earned, because if you play it many times, at least I will be able to check.
Yeah.
And I think that what happened in our experiment, that you tell the subject probability is 1 in 100, but for some reason, initially they think maybe it's more than 1 in 100, this is why they take it. After 2 trials of experience, say, oh, no, it's less than 1 in 100, and then they stop taking it.
Yeah, but here maybe I can defend the economic literature. Economists are well aware that deception should not play a role, and every experiment in economics and the LBIC should control for deception, for instance, by making subjects choose the color or let them gamble on both. And if you don't control for deception, the economic journal will reject your paper.
Yeah, but we think that maybe in real life, some people lie. Some of the description we get in real life are include deception. So I'm not sure how to connect it to the ambiguity literature. But anyway, this is a.
No, about deception, just a short note that the fact that you do not deceive the participant doesn't mean that they don't suspect some.
They don't think, yeah.
And what Ido was talking about, and this is again the experience part. So you have experience in real life in which you were not suggested such a proposal that were too good to be true. So you think that people will not do that. But this is why you assume it like in a very natural way, I guess, and it's not something.
But in economics, they are very strict. That can be like subject. In the last moment, the subject can choose the winning color. They do the experiment, so that it's very clear that in an experiment they could not have rigged anything. Economists are very strict on avoiding any perception of deception. So that's not a point to worry for economic experiments.
For economists. Okay.
So first of all, thank you for the excellent talk. We are unfortunately running out of time, so those who have to leave can leave. We still have some interesting questions here. So if it's fine, we will stay and continue the discussion for those who can stay. So Elliot, go ahead.
Well, one is a comment, just because we're talking about deception and one is a question. It stumbled into the classic line of economists think psychologists are unethical and psychologists think economists are naive on the deception line. It's a classic thing. It goes back and forth. It's always like that about whether, psychologists think that economists don't recognize that people think there is deception, even when they are completely convinced that there isn't. And economists don't like the fact that psychologists sometimes use deception. So classic thing. I've seen it go back and forth 100 times. I don't think we'll resolve that here. But I have a question related to ambiguity and the nature of the types of situations that establish ambiguity aversion. And one of the things that it has, or one of the properties that it has, which is actually very different than decisions from experience, is it has to be a situation where there's only one shot choice, right? It has to be the case, right? Because the game is very different if you're dealing in a multi-shot case, because the other thing you can do in that case is you can get feedback, you can get information, and you can explore, right? And that element of exploration is obviously not taken into account in the experiments on ambiguity. So do you think that's, in terms of how people regard these problems, do you think that an element of exploration, right, an element of what people decide to do on these ambiguity problems isn't only about what their ambiguity attitude, but is also about the information they might be able to gather, even if they can't actually use it in that case, but they might think that they can use it over time?
I think many experiments on ambiguity do not look at getting information or sampling just to keep it simple. But everybody in economics knows that learning is important. There are also quite some experiments in economics, also in, of course, this is, but also in economics, where subject can sample, can collect information, and where they study how people update ambiguous beliefs. And learning in itself, maybe not in ambiguity, but also in game theory, so it's a very big field in economics. So economics is completely aware of that. How to update is an important question.
So do any of the theories take into account the possibility that people, when they're making a decision on ambiguity, might also be trying to gather information, not just maximizing some sort of metric of local utility? Or is that not something that the theories ever take into account? The ambiguity theory.
If you must choose between exploration, expectation, must be repeated payments.
Right.
I don't remember now in economic ambiguity literature where they had repeated payments. For one thing, then income effects come in, it becomes more complex. So there, I know there are many studies on multi-arm bandit where those things are studied extensively. But but surely people will be aware of it. But at this moment, I don't know any ambiguity paper in economics that studied this yet. But maybe just because the other questions are already so difficult, we don't know how to handle them yet. But surely that should be studied. It's important. I agree fully there.
Thank you.
Ulrich?
Yeah, Peter, thank you for this great talk. You focused on individuals who played lotteries and I would say gambles against nature. I now want to bring it to the social domain and imagine there's an expert who knows the probabilities and a layperson who does not know the probability. Let's further assume that the expert is fully aware of the Ellsberg paradox. And if they now are in some competitive situation, they gamble against each other, or I mean, each gambles against nature, but they are put in competition. Is there a way that the expert can exploit this gap of knowledge between these two?
Probably, but maybe if the non-expert is aware of the situation, the non-expert will be very careful. I should say there have been studies, also papers that I worked on, where ambiguity attitude was studied when it was another decision maker and even in a game situation with strategic interactions. And their ambiguity attitudes are a bit different, maybe than when it's nature, the uninterested nature who you are playing against. So those things have been done, but where then some, I do know there are strategic situations in which one player rather have ambiguity than risk, because with ambiguity it gives the player more space to manipulate. I have seen things of that kind, but that's not exactly what you where the better informed person can exploit the ambiguity attitude of the worse informed person. I've also seen, for instance, in bargaining game theory, it can be good for you to make the other person think that you are irrational, think that you are very ambiguity averse, whereas in reality you are not. So where you can manipulate that to your benefit, such things I have seen. So they all come a bit closer. Not exactly your question. Exactly your question that I'm not aware of.
Okay, thank you.
Jackie?
Thank you. Thank you, Peter, for this excellent session, and Yefim for your interesting series that you've put together. I'm a practitioner in decisions from experience, and just completed doctoral work in ambiguity that relied on the research that you have explained so well today and developed. And I'm wondering, but this doesn't have to do with that. I'm wondering if deception could be reframed as trust and considered in an experiment as a trust variable, if you would have any comment on that.
Well, as I said, usually in economic experiments, they make very sure that subjects can be sure there is no deception, and then trust, there's no space for that also. So in that sense, your economics are stronger. So in economic experiment, usually that doesn't play a role. So they can then also not split. There have been paper, the trust game. Actually, I wrote a paper on the trust game, where how ambiguity attitudes impact the trust game. So but that's a different thing than deception. There was no issue of deception there. It was just whether a player was selfish or not, and whether you could trust on that. So exactly the question that you asked, I don't know literature about it.
Thank
Peter
you.
will know for the next time we invite him. And by the way, thank you for the comment. I have to share the credit with Kinneret, Ori, and Ido for the seminar. And Ori, you have a question. Go ahead.
Yeah, thanks. Great talk, Peter. Thank you very much. I now so much better understand theories of ambiguity in just a short time, so it's great. So my question is, what do, for example, the source method, what does it predict for a repeated experiment with feedback on ambiguity? So a repeated Ellsberg kind of problem with feedback. So it's a source. The source is still ambiguous. So it's not exactly repeated. So the erns change in every round or so. But you do get feedback on your choices. What would happen there?
Well, a usual finding is the more people can learn, the more ambiguity neutral they become. But even if they have perfect learning, they don't reach complete ambiguity neutrality. Something of ambiguity attitude remains. That's a general finding in the ambiguity, not particularly for the source method. And so I would expect also the more people play, the more people learn, the less the ambiguity attitude becomes.
So, but theoretically, I'm asking what's. So you're saying there's a different probability weighting function for different sources. What happens there? So you get feedback and the probability weighting function changes, or what?
Yeah, so the probability weight function moves more in the direction of linearity.
Okay, so with every round, you'd assume the probability weighting function shifts.
Yes.
Okay. So I could just tell you that I have an experiment with Yoram Alevi, and we actually show that it does completely disappears. Actually, a little bit flips, and
it even
also. Yeah, so yeah, actually, people there's a little bit of tendency to seek ambiguity at some point, even, and that also it also happens when you give people feedback on for some time, and then you start asking them Ellsberg types questions without feedback, then there's no ambiguity aversion left there.
Okay, remarkable.
So within the experiment, if you learn that no one's lying to you, by the feedback, ambiguity aversion is completely eliminated. So we're writing the paper now, but
okay, it's remarkable, yeah.
I know that we're not going to solve, as Elliot said, the puzzle about deception, all this stuff. But the thing is that, or at least my idea of of suspicion, is not something that you don't have to think about it explicitly. So it's not something that you think everyone is cheating you or something like that. It's just some suspicion that is not, you don't even know exactly to explain it to yourself, but it's based on some past experiences. So it doesn't have to be something that you acknowledge explicitly, and at least the way I see it.
Yeah, I can. One way that people try to explain ambiguity is that usually we are in social interactions, and then they say usually it's I do disagree. I think usually we're cooperative, but usually it's compared. So you, from social interactions, you have the instinct. If you don't know things, they will probably be bad for you.
Yeah.
And that social instinct, you misapply it in ambiguity because you think it's there the same. So if you don't know the probability, you automatically think it will be bad for you. That has been one explanation, and I disagree with many steps in that explanation, but some people, so that's a sort of misplaced social suspicion, which then would be underlying ambiguity aversion. It looks a bit like what you said.
Yeah, I agree, and I agree with what you said and what Skinas says. This is probably what the big difference between the decision from experience literature and the economic literature, that we want to, if we want to sit on the same table, which we really would like, because you guys are nice.
You're an excellent dinner.
We don't share some working assumption, and I think that that your working assumption are more restricted than ours. So you basically, in order to have precise analysis, you basically have to share the assumption that the subject believe what you tell them. And we basically relax this assumption, and we said that subject don't believe anyone. And sometimes they believe the wrong people, as we see in politics. So this is the question how we, of course, it would be really nice to sit together and to try to help create a better world. But it's very difficult for us with your working assumption, because you guys reject our paper when we submit, at least my paper recently, when I try to submit the economic journal, because I say, well, what is this working assumption? How, if I tell the subject don't lie to them, why would they think I lie? But we think that the subject do. And this is a really important question, how we can, and I think you help us understand that this is our problem. So this was really good for us to see. Because I agree 100% that your analysis is perfect under this working assumption, and we got it wrong under this working assumption. But the problem with this working assumption that we think is not a useful one.
Yeah, there are some things which I don't like the economic literature, because usually they do this random incentive where one of the choices is selected randomly and played for real, but they let the computer choose your choice. And of course, the experiment can deceive the subjects in any way which choice they choose. So always when I do experiment, I always try to do this, and that there's some bold data, physical, that they can see it's true. But this is one thing in which I think almost every experiment subject can distrust the experimenter, and this is happening for almost all the economic experiments. So in that sense, I may agree with you, there's more deception and distrust going on than economists want to have it.
Yeah, by the way, when Kinera just came as a graduate student, we tried to replicate our result with a card game to address this problem, but it didn't really have a large effect. So it really was such a time-consuming experiment, so we gave up on that. But I agree that this could be, maybe we should have invested more effort in doing that. This can help convince economists.
It's more challenging nowadays when most of the experiments are run online.
Yeah, that's even more. Than with the computer, you can deceive anybody any way you like.
Yeah, but also in real life, everything on the computer, and you can be deceived any way they want to deceive you.
Yeah, but maybe even if you do urns and balls, these magicians, they can still deceive you anyway. So maybe we should hire them for our experiments.
Peter, something nice that we found about the deception with my work with Ralph, we did a meta-analysis about cheating studies, and we found that people in cheating, so you give the participant opportunities to cheat. And we found that in experiment in labs that there were deception. So when the researcher deceived the participants, so the participants cheat less.
Mm. Ah, that's remarkable.
Interesting, yeah.
Peter,
Okay.
can you reiterate on the slide when you showed what you would like us guys to do, the probability with the 100 minus x, the slide
Yes.
about the,
Yes.
can you reiterate it? What was your
Yes.
suggestion?
Let me. Yes. Yeah. Okay, maybe I can tell a bit. In economics, usually events can be combined with different outcomes. An event is for instance, rain tomorrow, and then in this gamble, you gain 100 euro if rain tomorrow. In that gamble, you lose 100 euro if gain tomorrow. That way, the likelihood of an event has a meaning independent of outcome. But in decision from experience, usually, the event is defined by the outcome. That lottery, the event that gives you 100 euro, that's always the event that gives you 100 euro, nothing else. So the likelihood of the event and the outcome and the value are not easy to separate. Now you could do that. You could do a decision from experience experiment where you say you're sampling from this lottery, and in one either you gain what the lottery gives, or if we do a sort reversed, an outcome switch. We do, if that lottery gives you 70, we only pay you 30. If that lottery gives you 10, we pay you 90. So then the likelihoods remain the same, but the payoffs change. Then you can separate and then you can see, hey, when this event has a good, this good outcome of this event, indeed it gives a good outcome to the subject, he's overweighting. But if that event now gives the bad outcome, the subject is underweighting that event. Then you can see how the weighting can depend on the outcomes. Then, and I think that would be really good for decision from experience. Then you can separate likelihood of events from favorability of outcomes. And then you can investigate and test much more than what you're doing now.
This is very interesting. Thank you.
Mm.
Okay, guys, so unless there are other questions, I would like to thank you again for the very interesting talk.
Yeah, I was glad I could speak to this community.
It was our pleasure, and hope to see you all the next time in February.
Very good.
Happy
Good.
New Year. Thanks, Peter.
Happy
Thanks.
New Year.
Bye-bye, everybody.
Happy
Do
New
you
Year.
have minutes to stay, or you have to go? I can.
Sorry?
You have a minute now? We can.
I should give a minute, yes.
Yeah. Okay. So that was really fun talk.
Okay. Yeah. And it was a fun audience.
Yeah. Question is, but do you agree with me on the working assumption thing that that you guys take your working assumption more carefully than us? So the problem is with working assumptions. The question, what can we do against it?
I think indeed, in general, economists are stricter and more precise and maybe also more rigid in the things they are assuming and testing. In general, that's true. I'm not sure. I think you directed it to that subject may always be distracting and thinking they are deceived. I'm not sure. I already said economists are really very strong on avoiding any idea of that kind. So,
yeah. Okay, this is gonna be tough.
No, it's part of the assumption that, again, that people read the instructions. So in many economic studies, you have many complex instructions that if you tell them ahead from economic point of view, that's okay. So they have the information. But in fact, in many cases, they just don't read it. So
yeah,
then
that's true. Maybe economists have proved that there can be no manipulation, but the subject don't know. They just don't read. They just think people always deceive everybody, so they just still.
You know, but sometimes it's not even deception. For example, Yafim said people will be able to leave after the first hour of the seminar. But of course, people could leave earlier. He said you can leave then. But of course, they can leave earlier. So there are many situations that you see, you hear a description, and you know that they don't really mean it. You know, Yafim will not go after the people who left after 50 minutes and will write them better recommendation later or will shoot them. Mm-hmm. He just said that. So many times you get a description, But language is just a language. It's not fully precise. Nowadays, you see it also with the corona. There is when you enter in Israel, in many restaurants and other places, there is a sign: you cannot enter without a mask. But they don't mean it. They just left a sign there. The sign is there, even though the rule has changed. So many situations when you read signs, you know that the signs only suggest the fact that they said something. It only suggests that it used to be true once, or maybe it's often true. So I think we walk around the world when we see descriptions, we consider them as source of information that may be correct, maybe not correct, maybe because people try to cheat you, maybe because they're just like Yafim, they want to save words and not explain everything, and reminds people that they can live in the middle. So this is, I think that ambiguity is really, so the question how we can connect this to the economic literature. And